And from here, I can choose to take a new file. Okay, new Jupyter notebook. Now to have more cells like this available, you can either click on this or shift enter, I believe. What is it called? Enter. Shift enter gives you the new cells, or you can also click on this plus over here. You can name the file. For example, I'm going to call it Python basics. And here it is. Okay. See, first thing is, how do you create a simple Python script? Okay. Creating a simple Python script, for example, suppose I'm going to take a notepad. So I'll just save this as first class, or uh, just calling it notes, and I'm going to move it to this folder that I've just created, right? So now I'm going to take a new notepad and so I'm just creating some variables. Variable is nothing but, okay, let me just department, and I'm going to say IAF. Why is it within the quotes? This is called as a string. Anyway, we'll talk about it. Some salary, I'm going to say. I'm just calling it 1000. And department, let me call department as sales words. And I'm going to have some variable. This is good enough. See, this is called as a string. This is called as a numeric, that is basically integer. Right? Okay. Sorry. So I have a print statement here. Salary is as follows. And I'm going to call this variable sal. Okay. So this is my program, for example. Some program, simple print statement I have inside the thing. I'm just storing it as some example, but please see here .py. Any file, if you want it to be a Python file, it should be in the .py extension. .py extension. Now I've saved it. Now I'll go to Anaconda prompt. See, remember, if you have downloaded Python directly, then you would have just gone to command prompt. Right now, I have not downloaded Python directly. When I go to command prompt and say Python, it is asking me to download Python here, because Python is not installed in my machine. Rather, we have used some third-party tool called Anaconda, which gives us everything like Python with these development environments. I hope you get it. And if you don't, please feel free to ask me. So here, when I come to Anaconda prompt and say Python, I have it, right? However, what I want to do is, I want to cd change directory that folder which I have created, called it IAF, right? Yeah, here. If I say dir directory, it will show me everything in the folder. See, right now I'm in the C drive, this folder, and directory lists the files that are available. Now I want to run this Python file. So Python ex.py. And when I run this, it is printing exactly what I have included in the print statement. That is how my salary is 8,000, whatever. This is how we create this is a Python script or a Python program. Ran it from the command prompt. Okay. Now, so now we will come back and do this in the Jupyter notebook. And from here, please feel free to follow me. I mean, in terms of you work along with me. Okay. As I code, you also do it together so that we become familiar. So we are not looking at running the script from now. Rather, we would be looking at the Jupyter notebook environment. In the Jupyter notebook environment, what happens is, if you see here, if you go to the C folder, here, if we go, you can see there is a file ex which we created, which is a Python file. However, Python basics is IPython notebook file. Okay. What is IPython notebook? It's nothing but Jupyter notebook. Okay. Jupyter notebook was called like that before. Okay. Good enough. We'll go ahead and I'll let you try around these tools later, which is very, very simple. Okay. Let's say this is a code block. I want it to be some markdown or heading. Okay. I'm going to say that. And you can see, I'll say data structures. See, it has become some heading. Thus, I took that as a markdown. To run the code, I'm using Shift Enter. You can also use this button, run over here. Okay. And just give me one moment. I have a few slides. Don't use slides much in the class. But if you prefer me to use it, I have the slides. Okay. See a few things about Python. Python is case sensitive. Okay. I mean, while writing something, you should be aware of the cases, capital, small letters, uppercase, lowercase, right? Python is a high level dynamic object oriented programming language, meaning everything in Python is considered as an object. Pretty easy. It offers clean syntax, powerful extensions, good for text processing as well. And we will be learning text processing here, right? Python 2 or 3, Python 3 is definitely preferred. The major difference between Python 2 and 3 is Python 3 is more intuitive. In fact, one of the differences that are very notable is, in Python 2, print statement goes like this. Hi. In Python 3, it's not possible. It has to be wrapped. Any print statements should be wrapped within a pair of parentheses. Okay. All right. So installation, okay, we all have it. So we are good to go. Jupyter notebook is all fine. Okay, let's go ahead. Arithmetic operations in Python. See, Python supports all the arithmetic operators, like for example, plus for addition, minus for subtraction, multiplication, division, and on top of it, there are other operators as well, like floor division and so on. For example, if I go back here, yeah. But I have some numbers. b is equal to 4. And I'll say a plus b, uh, addition, subtraction, similarly multiplication, division. A divided by b is 0.5. Let me make it 17. Or let me interchange. Okay. So b divided by a. How much? 8.5. If I use a floor division operator there, it rounds the sorry. So basically, a slash, a forward slash represents the uh, divide operation. If I use double forward slash, it represents the quotient. And if I use the percent operator, that represents the remainder, the percent A. This gives me the remainder, basically. For example, so suppose I have 19 here, and I have, okay, show it to you again. 19 by 4 gives me 4.75. But if I go for a floor division operator, it will just round the quotient, 4. Similarly, what if I go for a modulo or a uh, reminder, 19 by 4 would be 3. It gives me the reminder, right? So 3 remains. In this case, 1 remained because it was 17 and the nearest one was 16. So these are some of the arithmetic operators available. That is plus, minus, multiplication, division, floor division, so on. You also have power and other operators. I'm not looking at all of them, right? So, okay. So with that, we will talk about how to print items. I'll give you a minute or two to execute this, and then we shall go forward. No hurries. So please tell me if I go faster or if I go slow. You should tell me. Okay. Um. See, today is our first day, so I do not know the level of expectation. Even if I go very slow, and if these things are already known to you and very basic, even then, please tell me. Okay. Just let me know if you're done. We shall go forward. When you're done, you just type it there. I'll go forward. So Jupyter Notebook is a notebook environment where in one cell, if you type and shift enter, you see the result right below that. So it makes it easier for our learning. Okay. This is not really used in the production environment. In the production environment, we generally write the code and run the script. Okay. So, all right. So upon your confirmations, I shall move forward. Okay. I hope we can move forward. If somebody is not done, please tell me. Thanks for the confirmations, whoever have done. So let's go forward. Now, a variable is nothing but, see, each one of us have a name for ourselves. So variable is also nothing but a name. For example, this operation results in some output, right? If you later want to use this output, this should be named. That name is called the variable. Okay, again, I've forgotten that you're from the computer science background, so that's not required. You know what a variable is? It's a identifier. So for example, I have a variable here. Hi, I am a string. So whenever I want to call this, I can use this v over here, which is the name by which this string can be called, right? Okay. Without much ado, we will now go ahead understanding the data structures of Python. Okay. So I got one variable here, which is actually a string. How do I identify that? See, in Python, if you use one comment, one hash, it is called as a comment. So look at this here. It is a code cell, right? It's a code cell. But I have added this hash here. Now, if I run it, you can see this did not run. I mean, this is just a reference. If I remove it and run it, it is an error. I can also just call it markdown here and add a hash here and like this. String, or let's call it strings. So what is a string? String is nothing but characters. Characters meaning letters and words and sentences, right? That is actually strings. However, anything wrapped within a set of double or single quote is a string, everybody. So now you can see, if I look for the type of this, type of V, and please remember, I don't type everything completely. When I say TY, I will use this tab. Tab, if I hit the tab button, type of V is the string. So this V is of type string. Now in each of these data structures that I'm going to learn, we are going to learn. Okay, let's take one more here. Let me just say there are, I'm sorry, there are ordered data structures, there are unordered data structures. Data structures are nothing but the building blocks of a programming language. It is a set of rules as to how a data should be considered. Strings, lists, and tuples are ordered data structure, and sets and dictionaries are unordered data structures. What is an ordered data structure? The first thing we are looking at is actually strings. See now, suppose I want to access this IM. How do I do that? Suppose I just want to access this I, which is in capital. I have to say, you see, length of V, for example, 15. We have 15 characters here. You see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are only 12 characters. This space is also included, 13, 14, and 15. Okay. The length of this string is 15. Suppose I want to access this I. I is in which position, everybody? Whenever you want to access an item, in all the data structures, all we are going to learn is more hashes I put, the smaller it becomes. That is Jupyter Notebook's characteristic. Okay? Nothing to do with Python. Accessing items in arithmetic operations. We learn about the inbuilt functions. Also look at the item assignment, which can be called as mutability. In each of these data structures, strings, lists, tuples, sets, dictionaries, these are the things we will learn. These are the characteristics we would learn, features we would learn. Okay. First thing is accessing items. What do we mean by accessing items? I have a string here. I want to access this I. Okay. So how do I do that? I can say V of 1, 2, 3, 4. See, when I say 4, instead of this I got the apostrophe or a single quote. Why is it? Because Python index. Index is nothing but roll number, everybody. Okay. We are 12 people in the class. Okay. I'll just go with whatever order I see. For example, see, we are a collection of 12 people, 11 people in the class. First, I can see my name. So I'll assign a roll number to myself as 0. Anurag, 1. Ganesh, 2. Jatin, 3. Jitender, 4. And so on. What is it? It's just a roll number so that we can easily be called, for example. Similarly, this is also roll number, but that is index. But in Python, index starts from 0. Please do remember, and end index is always exceptional or exclusive, let's call it. What does that mean? If I say V of 3, then I get the capital I that I was desiring for. So H is 0, I is 1, space is 2, I is 3. Capital I is in the third position. I can see that. Okay. Now, suppose I want to access I hyphen and M. Okay. From here, I want to access everything. What can I do? See, if I say P of from third, I want till 15 because we had 15 characters, right? If I say till 15, I have everything. If I say till 14, you see, P of 14th is the last thing. That is the G. G is in the 14th index because it is 0, 1, 2, 3, 4 like that because it starts from 0. 15th item is actually 14th position. I hope I'm not confusing with you with that. 15th item is in the 14th position because the index starts with 0. Now G. Now if I say I want to access everything from 3 to 14, last item is not available. This is because end index is always exclusive. So if you want to access the item in the 14th position as well, then you have to call 15. That clear? Maybe a few seconds. I'll let you do this and then we'll go ahead.
Sir, how can I run multiple cells in this notebook, sir?
Sorry, there was a question. How to run multiple
Sir, how do I
cells?
run multiple cells in this notebook, sir? Whenever I press Shift Enter, it executes the current cell.
Correct. So in the notebook environment, if you want to run the multiple, see the notebook editor is actually not for running multiple cells together. That's why we call it, we call that as a script where you run everything at once. I mean, Jupyter Notebook is not for that actually. But though you have an option to select, that is by going here, clicking on it, and then something like this, it can be done. Okay. But that's that's how it is done. If at all you want to do it that way, go here,
Hmm.
shift select, shift enter. Um, Sorry, was that a question to me or? Okay. Start index is inclusive and end index is always exclusive. Have you guys understood it so far? Are we good?
Yes, sir.
Okay. And guys, and everybody, feel free to call me Pawan. In fact, at the beginning of this program, I had a confusion because though I have done training to all levels of corporate people, like when we talk about corporate segment, doesn't matter whether somebody is a director or anybody, there's a culture there where you just exchange names. And here, I have high regards for all of you, and I was confused how to address the class because I don't know which positions uh, all of you are in. And finally, I chose to just keep it simple and call you by names. Um, so feel free to do the same from your end as well. So, shall we go forward?
Yes, we can go forward.
Yeah, thank you. So we have learned accessing item using the index. We've also learned accessing multiple items using, this is called as slicing, the word for this. Anyway, um, again, suppose I want to access only this much. Okay, I hyphen M. How do I do that? I can say 3, 2, 4, 5. To 5, if I say M will not be available because M is the end index. 3, 4, 5. So I have to say 6, right? 3 is to 6. This gives me IM. Suppose I want to make it, okay, I want to replace it as IAM. What can I do? Can I say IAM is what? This apostrophe has to be A. Okay. Can I say IAM? String object does not support item assignment. Please note that. So first thing, we have learned accessing items, that is through index, like this, like this. There are other ways also. For example, if you say v of keys to everything, this gives you everything. Is what? I am a string. From here, I'm able to access everything. Similarly, I can say b of everything till 4, for example. You see? Everything till 3, if I say, I have this. I have this slice of string. End index, start index, if you keep it open, it will give you everything. Similarly, I can also choose to have, okay, slicing we have understood. That is accessing items we've understood. The next thing I am talking about is item assignment. You can see that the string object does not support item assignment. And is there a way we can still do what we want to do? We want to change this I apostrophe M as IAM. What can we do? This item assignment string doesn't allow. So what I can do is basically I can look for some logic. For example, I'll go for V of 3 is I, and I'll take the plus K, what I wanted to add, plus V of 4 is apostrophe. I have already replaced this apostrophe, right? So, for example, V of is to 6. So this apostrophe, we wanted to replace it as A, but string object does not support. Once it is created, it does not let you do the reassignment of item. But there are still ways to do it. There could be many ways. One of it is we took the item in the third position, that is I. Then we added some A to it. Then we will take the item in the fifth position, that is M. So we have the available to us. So string object does not support item assignment, which is called mutable, meaning it does not lets you change an item which is already there directly, but indirectly is possible. Okay, I forgot to tell you another thing. See, string, if you want to access it from the end, you can also use a negative index like -1 in represent this G from the right hand side. Okay, I hope it is clear. I hope you are working along with me, and I hope we are good to go. Please stop me in between if that is not clear. So let's go forward. We have looked at the item assignment of a string. Now let's go ahead looking at the operations, arithmetic operations. Very simple. See, I have a string here called banana. I have another string here called orange. Can you add these two strings, A plus B? Possible. Can you multiply character with character? Not possible, isn't it? Can you multiply it by some number, banana, twice? Possible. Can you add it with a number? Not possible. If you want to add it with a number, these two should be converted as a string. You can do it this way, or you can do it just by placing it in the quotes, be it single or be it double quotes. So the operations possible with a string is very common, very easy. One string can be added with another one, but you cannot multiply these two, right? Rather, you can multiply this with a number. Banana into 2 will give you 2 bananas. Banana into orange, not possible. Banana plus orange is possible. Banana twice, thrice is possible. Or if you want to add a number to a string, you can convert that as a string by calling it within a single or double quote, or by calling it as string. Okay, so I'll let you. I hope you are working along with me. Again, please ask me if I go faster. Tell me. Okay. Um, let's go forward. So we have looked at accessing items, arithmetic operations, item assignment. We'll look at the inbuilt functions. See, once you know the index part of it, right? Whenever you want to access an item, yeah, go ahead, please ask me. Any point of time you can, ask a question. Can we have fruit one is banana and two as orange? Okay. Do you mean can you have a uh, can you have banana named as one? Is that what you mean? You cannot name it as one, but you can call it as fruit one because the naming in variable name is an identifier. Okay. Though today we see, it's just take it as a humor. Today we see Elon Musk has named his child by something along with, that is what I meant, fruit one. Fruit one is possible. So there are some naming constraints. Cannot start a name with a number. This is fine. This should be fine. Fruit one is fine. Okay. So naming a variable have its own rules that are generally, you see, a name cannot start with a number. It cannot have these characters, but it's all very, and you should not use any of these functions as a name. For example, we don't name our children as building, street, city, something like that, right? Because they have their own meaning. So like that. We should not be using any keywords as a name and so on. Anyway, so so now coming back, this accessing of items, right? It's gonna be same for all the ordered data structures. Later, we'll learn NumPy, pandas. Even here, indexing is same, okay? Accessing items remains the same. Okay, so we have seen all this accessing of items, arithmetic operations, item assignment. Now we go to the last part, inbuilt functions. Okay, it's very, very simple. So suppose I have a string by the name fruit1 called as banana. But when I run fruit2, it gives syntax error. Okay, I didn't see it. But do you mean fruit parenthesis like this? Yeah, special characters are not allowed. So I don't know. Parenthesis is not allowed. Okay. Other, you can use an underscore. That is allowed. Underscore is allowed. So these special characters are not allowed. This is allowed, underscore. Okay. Okay. Suppose I have a fruit by the name orange. P is of type string, isn't it? Now, please carefully observe. B dot, I will give a tab here. You can see capitalize, case fold, center, count, encode, ends with, find, index, is alpha, is decimal, is digit, numeric. There are so many functions available for date object. Remember, Python is an object oriented programming language. So everything here is considered as an object. However, For any object of type string, all these functions are available. For example, if I say capitalize, okay, by the way, here, okay, if I say capitalize, what is this function doing? If I run it, suppose, I'll have to call the function by using a open and close parenthesis, shift enter. What has happened here? This string orange, the first letter of the string is been capitalized. We can very well see it over here. How do I know what this function will do? Before this parenthesis, you do a shift tab, and then you can see it return. This function is available for objects of type string, and it returns a capitalized version of the string, that is, make the first character capitalized. And what is this called? This is called a document string. See, somebody, while writing this function, they wrote a reference, that is document string. For example, see, I wrote some comment here. What is this comment? Comment is nothing but for the reference, right? If I pass this file to somebody tomorrow, if they have to understand it, so I'm gonna put this. For example, when they run it, they will see an error and they think, why is this man given all the wrong code here? We gave it purposefully to make people understand that the string object does not support item assignment. So we have a comment here, reference, so that people understands it, right? Similarly, in Python, multi-line comments. See, single line comments are one hash, right? This is a single line comment. One hash, if you use, it's not a code, it's a comment. We know it. Similarly, if you want to have multiple lines, then you can use three sets of quotes, single or double. Okay, so we have to say this is a multi-line comment and it spans for more than 2 lines. Simple example I'm saying. So you can say, when I write this, there is a character here called /m. This /m is actually representing this /n is representing that this is in a new line. It's not in the same line. So using this multi-line comment is called document string. Okay. So coming back over here, so any object of type string will have all these functions inbuilt, which are available by default. Okay. So when you use capitalize function, capitalizes the string. Similarly, b dot, any other functions over here. For example, is upper. If I just run this, see, I have not called the function. Function is always called using these parentheses, set of parentheses. So I have not called the function in this case. So the function string is upper. It is just saying this is a function available for string and the name of the function. But if I call this function, now what it will do, I'll go here, shift tab, if I press, it will say this function is Boolean. It returns true if all the cased characters in the string are uppercase and there is. That is, if the string is uppercase, it will say true, but in our case it's false because the string is not in the uppercase. It's a Boolean function. So we can also seek help of a function. For example, b dot. There is a function called find. Okay. Suppose I don't know, I'll go for it. Return the lowest index in S where the substring is found. Suppose I want a detailed help. I can call for help this way. Help of this function. You can now see it returns the lowest index in S where the substring sub is found. For example, if I say b dot find and O, see the string O is also found. Okay, orange, it only is, yeah. So it is returning anyway the index where the substring is found. So of course, we will not look at all the functions available for a object of type string. If you want to look at how many functions are available, you can say b underscore underscore b dot underscore underscore dir underscore underscore, and it will list all the functions. See, these are the functions which are available for any object of type string. These functions are also available, but these are available for all the data structures. For example, there is something called contains here, right? See, in Python, this underscore underscore is called as a magic method. However, let me not rush through. See, when I say, sorry, uh, see, when I say b dot, these functions that I am seeing here, all these functions are available, right? For any object of type string. These functions are listed from here to here because these are special for strings. Whatever is underscore underscore, right? These are inbuilt for everything in Python. For example, underscore underscore dir underscore underscore. What this will do? It lists the all the methods or functions. Similarly, suppose I want to add this contains thing I want to use. What do I do? I'll say p dot underscore underscore contains. Suppose I will say f false. The string b do not have anything called f, but it has something called g in orange, right? Similarly, I can say b dot underscore underscore add orange org. You see, I'm able to add. Can add an underscore there, right? So that's how these inbuilt functions are made use of, everybody. There are a lot of other functions. In fact, I can give you some tasks here as well, but I think I'm not going to do that if you have understood this well, because we don't want to spend a lot of time in Python itself. So we just need the basic understanding of Python so that the journey is smooth for the next 5 days. Is upper, is lower, we've seen. Then replace, for example. See, old, new. Return a copy of S with all occurrences of substring. Suppose I'm going to say replace A with O. You see, orange has become orange. Like this, there are functions. Okay. So we will not look at all the functions that are there in the strings. So I hope we are good. Once you're done, please let me know. We shall move forward, everybody. Right? Um, thank you. And we shall move forward with that. So now we are done with strings and we want to move to lists. So there is another function here. Suppose I have this string called v, right? Hi, I am a string. And now I'm going to say v dot split the v upon a separator. Okay. If I say v dot split and does not mention anything, default separator is a space. So hi became one string, I am became one string, another one, and string another one. So now if you look at the length of v, it's 15. Oh, I'm sorry. I didn't assign it to anything, right? So I'm going to call it L. Okay. So look at L. The length of L is of course 4 because it has 4 items. It has 4 substrings in it. What did we do? This string is split into 4. Upon encountering space, it is split. What if I would have said v dot split by quote, for example? This apostrophe. Now you can see this has become one string. This part has become another string because I wanted to split this string upon encountering this quote, single quote over here. Okay, anyway, so we have created this L. What is the type of L? Is it a string, everybody? Is L a string even now? Um,
No, it seems like an array of this.
uh, that's right. Just the name is different. It's a collection of items now, but it's a collection of strings right now. It is called a list. Okay, type of L is a list. You can see type of V was a string, but this string is divided into a list of substrings. Substring is nothing but smaller strings. So this is a list right now. So I told you the strings, lists, tuples are all ordered data structures. So if I try to access an item from it, for example, if I say L of 0 would be the first item. So L of 4, will I get the result if I say L of 4? Anybody? See, this is 0th item. This is first item, second item, third item. So 4 would be list out of index range. List index out of the range. So I have to say 3 itself. However, can you say how I can access? I am a string. What can I do? Should I say L of 1 to everything? Yes. L of 1 to 4? Fine. See, though there is not a fourth item, 0, 1, 2, 3 itself. So 4 has to be given because Sharp index is exclusive, isn't it? So I hope all of us remain in the same page and none of us are missing out on the basic indexing part, because later it will be difficult to catch up. So please feel free to ask if there is a doubt here. Okay. So that's a list.
On, can you print L of 1 to 3?
L of 1 to 3, what
Yeah.
happens is, see, this is L, 1 is this item, 2 is this item,
Yes.
3 is exclusive because third item is not printed. So only these two will be printed. L of 1 is to 3. One is start index is inclusive, stop index 3 is exclusive. So 1 and 2 will be printed. So if you guys need, you can take a minute or two and play around. I mean, try with the indexing itself, like slicing, etc. For example, if I say L of everything till second, then I'll get the first two items, 0th and first item. So if I say L of third till everything, anyway, third item is the last item, so I only get the third one. Otherwise, if I say from 2 to everything, I get everything like this. So I hope on that part, indexing, we don't have any confusions. Please move slider up. Do you see the chat window or this slider? Okay, you guys see the chat window as well, is it? Okay, so from here, is this fine now? So it started from here. So yeah. Okay, so now that we have just seen list, we have also seen how to do how to access an item from a list, we shall move forward. I'm going to create a new list right now. Okay. I'm calling it as L1. List is called as a collection object. Okay. And it can have anything inside of it. List is one of the most useful data structures generally because you can have anything inside a list, everybody. Okay. What by anything? What I mean by that is, see, I have a string here, suppose banana. And let me have some integer, 5. Let me have another string here, orange. Let me have another integer, 8. Let me have one more string here, white. And let me have one more string here, 5.8. So you see L1. L1 is a combination of strings, numbers, integers, float, everything. You see, type of L1 is a list. Type of L1 of first item is a string. Type of L1 of first, second, 0, 1, 2, 3, 4, 5. Fifth item is a float. So list objects allows you to store anything inside of it. In fact, I can have another list itself inside a list. For example, I can also have it something like this. You see, hi, hello, 100. See, now you have another list inside a list. So if I go for type of L1 of 6, see, this sixth item is another list inside this original list. These are called nested lists. Okay. So how do I access this hello over here, for example? So I have to say L1 of sixth item. Then I have to say the first item is hello. Suppose I want to apply some string based function to it. So I can call it because L1 is this hello. What is the type of it? For example, this is a list inside this big list. However, if I go for it, type of L1 of sixth item of first item, this is the sixth item of this list, and inside of that, this is the first item in this list. So L1 of 6 of 1 is going to be this hello. Type of it is a string. So I can apply all the string based functions. So this hello, the H is now capitalized because I am able to apply all the string based functions on this. By the way, how is a list created? A list is all. How is a string created? When you talk about a string, whatever is wrapped within single or double quotes is called a string, right? Similarly, list is always wrapped in a pair of square brackets, right? Tuples. separated by comma, but by convention or by standard, by a pair of parentheses. Go there, but first we'll finish this. So I'll let you execute this and then we'll go forward. Please ask me if there is a concern, if you want me to recap anything, if there is a doubt, please do ask me. Okay. So let's go forward. I'll keep this open for a moment so that you can try it yourself. Shall we go ahead? Are we good with indexing? Hope we can move forward. Or do you want me to hold for a moment? Okay. So we have created a list. We have seen the indexing. Now let's go ahead. What else do we generally see? Item assignment we have seen. Arithmetic operations, again, nothing to see in terms of, again, this is a list where you have both string as well as numbers. So it's quite complicated. However, within the list, you can access any of these items and apply arithmetic operations. Now moving to the mutability. For example, L1 of 2, you have orange. I'm gonna make it oranges. Look at L1, done. So list is mutable. That means item assignment is okay, possible, it's allowed. Item assignment is allowed. This is fine. Now, looking at the final thing, that is the functions of list. There are a lot of functions that are inbuilt for a list. There is append, there is clear, there is copy, count, extend, index, insert, pop, remove. There are so many of them. For example, pop, if I use, this last item will be popped out. Okay, so if I use L1.pop, you can see this is deleted. This last item is deleted. So if I say L1.pop and if I say 1, then this first item will be deleted, whatever is in the index. Similarly, L1.remove, remove first occurrence of the value. For example, if I say remove height, see L1, this is deleted, this is removed now, this was also deleted. L1 remains with only these 4 items now. There are so many other items, functions. Append, for example. See, appends an object to the end. For example, let me try appending hi, comma, hello. Okay, let me just try put one item. What has happened now? Appended to the end. Okay. Similarly, there is extend. Okay. L1.extend of k. What this will do is, you see this one string we added as 3 substrings. That's what extend do. So simple difference between append and extend. If you see, I'm adding hi, hello, another list using append. Now, if you go back to L1 and check, this is added as another list. Instead of append, if I use the same thing and put an extend here, now if you come back, see this hi, hello, this was append. But look at this extend operation. Hi is another string, hello is another string. It did not come as a list inside of this whole list. I hope that is clear. And let me just remove this H, E, and Y. Make this string simple. Okay, I hope you understood the differences between append and extend. Similarly, there are a lot of other functions. Of course, we will not look at all of them. See, there is something called insert. If you look at it, it will help you insert an object before the index, right? For example, new, I will say, before 0, that means, sorry, before 1, I'll say, okay. So, first thing is index, then object. So this order was wrong. So I'll say 1. Now, if you go back here, You see in the first index, new is there. Oranges is moved to the next index. This is insert. Likewise, there are a lot of other functions that you can look at. Sorting a list, example, and so on. L1.sort. It's not available right now because you have both characters as well as numbers. So if you had a string where it was only character, then you can see L, hi, I am a string, L.sort. Or suppose you have a string where you have 100, 500 and 50. Now you do L2.sort and look at L2. You can see it's been sorted in the ascending order. You want it to be descending order, reverse is equal to false is there. So you make it true. Now you go here and see it's in the reverse order. How do you know something will be there like this? All you got to do is help of L2.sort and go here. I don't see a detail. Okay, there it is. So now you go here and look at, sorry. Okay, this is all the documentation is available right now for this. See, this is a argument. This is called as an argument, which is already there, which is by default false. By making it true, it is going to be a reverse sort or a descending sort. Okay, so I'll let you work on this and then we shall move forward. Please do ask me if you have any questions, any point of time. Please do ask me. Okay, so with that, I hope we've understood strings and lists in terms of accessing items, some of the inbuilt functions that are available, and how to do the item assignment or what kind of operations are possible. With that, shall we move to the next data structures? So what are we learning? What are these data structures? Basically, the building blocks of a programming language in terms of now whenever there is a string, what kind of operations are possible, what kind of functions are already available, right? Same goes to the list, which is a collection object. And right after this, we will be moving to another ordered data structure, which is a tuple, by the way. I'm okay if you'd like to take a little couple of more minutes, but just let me know once you're done. If you have a question, please ask me. Are we all good so far? Any questions? So basically, list is a collection object. So it lets you put everything in one basket, be it a string or be it a integer, float, or another list itself. Everything can be put together in one basket, and you can do all the operations possible. Use all the functions that are available for any object of type list. Once we are done with that, we'll move to tuples. Okay. Let's move forward. Shall we? Are we all good to go ahead? All right. So the next topic is tuple. So let's go ahead. Tuples. Just in case, I just wanted to, enlighten. See, if you feel this is very monotonous, exploring one data structure after another, I mean, if it's kind of a boring, I'll tell you, once we are done with the learning of Python programming in terms of, the essential things that we should understand to move forward to data science. Once we are there, it will be quite interesting. And if you'd maybe later, I can also see whether there are some sort of data which you would be interested in, and we can also work on such data. Uh, so yeah, okay. The tuples. Let's work on tuples. So what are tuples? Tuples are pretty much like a list, okay? 1, comma 2, comma A, comma B is a tuple. You see, is a tuple type of T is tuple. By standard, by convention, we don't write it like this. Even if you create it like this, it is indicated by a pair of parentheses, which is what I have given over here. What is the difference between a tuple and list? See, list is in, consider L1. See, a list is in the square bracket, tuple is in the parenthesis. Apart from it, here also you can have different type of data. Here also you can have different type of data. So there is no such difference. There is no huge difference as such. Okay. Tuple is generally used when the data is kind of volatile, kind of static. Okay. What does that mean? When the computation is less, for example. So the major difference between a list and a tuple is actually tuple, if I say T of 2, okay, T of 1, which is 2, right? I try to make it 20, tuple object does not support item assignment. It is the major difference between a list and tuple. List is mutable, string is immutable. Similarly, tuple is also immutable. Okay. Tuple is also immutable. So tuple can be used when you do not want the user to be able to change your existing code or existing something in your application. If you do not want to allow the user to change something, you can go for tuple. Otherwise, everything else remains the same. Like list. For example, here as well, suppose this is my some string. Okay. Now I can say T of third item, which is banana, and I can use this capitalize function just the way we used on a list, because this is a string inside a tuple. So if I say type of T of 3, it's anyway a string. That's the major difference. Apart from that, tuple do not really give you a lot of functions. Count is one function. Return the number of occurrences of a value. For example, if I say T of A, it says t dot count. Okay, A is returned once. That's what it is returning. So if I have another A, go for it. It's returned twice. Ask me what if I want to count the number of A's inside of it. For that, you have to look for the string function, right? That's a string inside the tuple. T of 3 is banana dot. And then you look for, there again, you had find function, for example, right? Okay. T dot count, T dot index. Index is again returns the first index of value. For example, if I say A is present in the second index 1, 2, 0, 1, 2. So these are the only functions available for a tuple. So tuple is mainly used when you want your when you do not want your user or the end user to control to change anything written already. So once you're done with this, we shall go ahead talking about the unordered data structures. See, I have mentioned ordered data structures here, strings, lists, and tuples. And I have also added these two, NumPy and pandas, which are actually not native to Python, right? Whatever we did in the morning, the notes we have created, for example, we have clearly mentioned here that you see, Python data structures are uh, strings, lists, tuples, dictionaries, and sets. These are external packages, okay? But they are also ordered in nature. So I have added that. So right after tuples, we are jumping onto sets and dictionaries. Nice. Okay. Shall we? Any questions? So we have to cover another two data structures. That is, we have dictionaries. Dictionaries, again, as the name suggests, are unordered data structures. First thing, that is it doesn't have the order like we saw before. All these, so far we've been accessing items through some index. It's not the case with the dictionary, and they are key and value pairs. So we'll go ahead with dictionaries once you're done with tuples. Sorry, I was on mute. I'm trying to unmute. Yeah, so I hope you were able to try this out. You know, the major difference between a tuple and list is a tuple is immutable. Otherwise, they're both almost the same. You can have a list inside a tuple, tuple inside a list. For example, T1 of 1, comma 2, comma A, comma B, for example. So you can see I have a tuple list inside a tuple, and vice versa. Everything is possible. Moving to dictionaries. Okay. So what are dictionaries? Dictionaries are nothing but key and value pairs. Okay. What do we mean by key and value pairs? Okay. Let me call it as a address book. Okay. I have a new dictionary by the name address book. Dictionaries are always represented by a pair of curly braces. Okay. I have an empty dictionary here, for example. So look at it, type of address book. It's a dictionary. Now I can keep adding the keys and value pairs. What do I mean by keys and value pairs? For example, see, key is a hashable item which holds all the value related to it. by the way. For example, I'm gonna have a key by the key, and the name of the key is name. Okay, and here I'm gonna have some names here: Kiran, Aman, Monica, for example. Okay, got address book. Now you can look at it. My dictionary has one key and some value associated with it. Now, if you say address book of name, we have three values along with it. What is the type of these values? What is this data type? Anybody? What is this data type? Yeah. So it's a list of strings, isn't it? So now, if I want to access a particular guy from this, I can have the index. Is dictionary ordered? No, dictionary do not have indexes. To call these values, only way is to call the name of the key, right? However, this is a list of values, so you can make use of the index. Okay, so similarly, address book of, say, I'm gonna have some maybe marks or salary of these people. Okay. And here again, I have some salaries, 48 and 84, whatever. Okay. So now if you look at the address book, it has two keys, name and salary, and pair of values. For example, salary, you wanted it to be very confidential. Nobody should be able to change it. We can write it in a tuple, for example. Instead of a list, I can make it a tuple, right? So how do I access this salary? I cannot use index here because this is a dictionary. Index doesn't work. I have to call that unique key. Keys are unique, remember, right? Keys are unique. So how do I create a new dictionary, for example? If I want to create a new dictionary, suppose I'm going to call it D, and I can say, for example, one string I have, country, and maybe some value with it, India, and okay, let's have a list of values, maybe India and USA. Example, this one key with values, and you have state, and sorry, you're gonna have Karnataka, California, for example. So I've got a dictionary with keys and value pairs available there. So I can say d dot keys to fetch all the keys that are available in the dictionary, d dot values, fetch all the values available, d dot items to fetch all the items available. Right? And what else? The inbuilt functions, if you look at, there are functions like, okay, items, keys, we have seen. Items gives you both key and value pairs. Keys gives you only keys. Values gives you only values, for example. And similarly, you've got other pop. You know what pop it did in the list, right? Same thing here. It deletes the last item. Then you've got item, okay, update values we've seen. These are some of the functions available for a dictionary. So what time do we go for lunch? Is it 1 o'clock?
Yeah, okay, we can break for lunch and
Yeah.
yeah, then after say half an hour or what do you say? How much time it will take?
Okay, generally it's an hour.
Okay, so we'll take a hour break for lunch.
Sure. Okay. And before we leave, I just wanted a confirmation. Are we all on the same page? Are we going in the right direction? Is it getting too slow or faster? Or you wanted me to engage you in some of the activities? Uh, what's everybody's opinion so that we make sure we are getting the 100% out of this program? So are we all good, everybody? Anything you think can improve the
What
class?
can be done is maybe towards the end some exercises can be given. So whatever basics we are undergoing, so this in our spare time we'll practice the exercise.
Yeah, definitely. We will implement that. Sure. Thank you very much for adding that. So, okay then. So we'll catch up after the break, everybody. Thank you very much. So we are coming back at 2 o'clock and continuing the class. Thank you very much, everybody. By the way, I'll keep this screen open so that if you'd like to execute this, you can do that. Welcome back, everybody. So I still see a couple of participants need to join. So I believe we'll have to wait for a minute or two for them to join. Then we shall start. All right. So shall we get started, everybody? Okay. So we've been exploring a couple of data structures that are present. So as part of it, we have seen we've looked at the strings, lists, tuples, as well as dictionaries. So moving forward, we shall go ahead, get into We've also seen dictionaries mutable, isn't it? So, for example, this is our dictionary, and if I access state and say that's a capital S, Python is case sensitive. Do remember that. Say I want to make it NYC, and if I go back now, so the item assignment is pretty much possible. So it is mutable. Okay. All right. With that, we shall move forward to the last data structure that we will be discussing today, that is sets. Okay. So what are sets? Sets are nothing but the unique collection of items. Unique collection of items. Whereas dictionaries we were looking at, dictionaries are key and value pairs, isn't it? Okay. So how do you create a set? For example, suppose I have a list 1, 2, 3, 1, 2, 3. Okay. This is the list we have. If I view it as a set, you see it's a unique collection of the items. So only the unique numbers come here. How do you create a new set? For example, if you have to create a new set, then we'll say, suppose S is equal to, just put that in the for example, HD, ML, again HD, again ML. So if you wrap it in the within the curly braces, it will be a set of unique values. So HD when I say Hadoop, ML when I say machine learning, general terms that I mean generally this is how it is used. So say AI is included. Suppose I'm going to create another set where I'm going to have science, maths, and AI. Now, common operations with the sets are, suppose S dot intersection S1. What does intersection do? It will look for the common items, right? Which can also be written as S and S1, right? Can also be written like that. Similarly, SR. R is generally represented using the pipe operation. SR S1, meaning everything in both of it, both the sets, everything has come, which can be written as S union S1. Similarly, there are functions like difference, for example. S difference of S1 would be the two items, which is not there in S1. S1 difference of S would be everything apart from AI, that is maths and science. So sets are generally used to I mean these are unique set of collection of items, generally to differentiate between two group of items, like the basic terms like union, intersection, to find the common in two different groups, for example. These are the cases where sets are used. Okay. There are also other functions here like subset, superset. If you look for S1, is it a subset of S? Of course, it's not. If I create S2, which is suppose Let's say ML and AI, for example. Now is F2 S2. Okay, did I not run it? Is S2 a subset? Oh yeah, sorry. Is subset of S. Because S has these three items and in which it has two items, so it's a subset. So rather than that, you can also check, yes, is it a superset of S2, right? Sets are used to do this, these kind of comparisons between the unique collection of items. Okay, so with that, we are done with the data structures of Python. I'll let you execute this a minute or two. And at the same time, please do ask me if there is a question. I see drop in the list of participants. Okay, now I think they're all back. All right. So, all right. So sets is as easy as it is. It's a group of, again, it's a collection object like list, tuple, and dictionary. And two things, it is only unique collection of items. And the functions that are there, which are built for sets, are mostly to compare. Intersection is to find out the common from both of these sets. Union is to find out all the items from these two sets, which is nothing but and or operation. Similarly, difference is superset, subset. These are the kind of functions available for sets. Okay, take a minute and then we shall move forward. I hope we are done. So far, what all have we explored? If we look at, we have been looking at we have seen the arithmetic operators of Python, basic arithmetic operators, followed by we've started talking about strings. So these are the four things we've explored in all the data structures: is accessing items, arithmetic operations, inbuilt functions, and item assignment. So strings and tuple does not let you do item assignment. So they are mutable. Lists, lists, dictionaries, both of them allow item assignment. Okay. Anyway, sets, you don't have a way to access items itself, right? Then we have looked at commenting, using a single line comment, also multiple line comments. We have seen what a string is, how do you access item, what are its inbuilt functions, some of the basic arithmetic operations possible on string. Then we moved to list. Again, very basic of lists is what we have explored so far. That is creating a list, accessing index, pretty much basic. Also inbuilt functions. Tuples, again, about the same amount of thing we've explored. That is, how do you create a tuple accessing item? Very few inbuilt functions it has. Then the dictionaries. How do you create dictionaries? Are key value pairs. You can access the value using the unique key name, right? Similarly, sets are unique collection of items. That's all we have explored so far. Now going forward, we would explore further in terms of, okay, see in the data structure itself, I mean, later, this is for your homework. I mean, you can do it after the course. There is a module. I'll tell you what a module is. It's an external package. Sorry. There is a module called collection. Collection module offers something called as ordered dictionary. The dictionary is not an ordered data structure, right? But this module offers you something called as ordered dictionary. Similarly, there is something called named tuples, rows and sets. These are all data structures offered by this module for Python. You can go ahead, explore it in your free time. Okay, now let's explore print formatting. I want to ask you something very simple. See, have a variable called x. Let me call it balance. Okay. Suppose in my account I have 80,000 rupees with me. Okay. Now I want you to write a print statement asking the user to input amount he wished to withdraw in the ATM. Once he provide the amount, the figure, you display the balance. That is balance minus whatever amount he withdrew. Can you do that? Would you like to do it? Simple one print statement is all you have to write. So create another variable which is input should be of type integer. See, these are called typecasting techniques. For example, 8.75 is a float, right? So I can say int of 8.75. This is called typecasting, right? Similarly, I can say string of 8.75, right? These are typecasting techniques. So what I am saying is, whatever input the user is giving, make it an integer. And to ask the user input from the user, we use the keyword input. And here, enter the amount to withdraw. Okay? And now we are print balance is, for example, amount minus balance. Should this work? I want to withdraw 38,000. So 42,000 should be left. However, int and tuple. Sorry, I've given a comma there, right? Let's see, 42,000. So I should have done balance minus. Okay. See, this can be written using print formatting techniques as well. For example, here I can say print hi, your account number has a balance of, for example, and here I can use something called as dot format, and I can say sorry, for the first curly braces here, I want it to be, say, my name. Okay. Hi, Pawan. Account number 1288. Okay. Has a balance of balance minus amount. So what has happened here? You see, in whatever order in the dot format I have passed the variables, in the same order, the variables are here, passed over here. I can also have it in different order. For example, suppose I have this first. Suppose I have this first, followed by these two. Now it takes a task, right? Now what I can do, I can pass this to this place. I have the item in the first index should come. I want the item in the first index to be coming over here. Item in the second index is this to be coming over here. And the first one to be going to the last. And this gives us the right order, isn't it? So this is called as dot formatting techniques. If you did not understand this, please ask me. So basically using this dot format within a print statement, I can pass whatever I want to the print statement. So whenever print statement, whatever you pass within the code will be printed as it is, right? Any questions here? Shall we go ahead, everybody? All right. Thank you, everybody. See, there are more formatting techniques. I won't get to the details of it. It's again like typecasting, for example, an integer, percentage D here, I'm saying, okay. Go out of the print statement and then I say percent 8.87, for example. Because I have used percent %d, whatever is passed after this percent is taken as an integer. So I want it to be converted as a float, for example. Suppose I have 8, converting it to a floating point number. So like that. Similarly, we can convert it as a string, raw string, etc. These are IPython magic operators. So, okay. So these are some of the print formatting techniques. Not just this, there is also something called f string and so on. Let us not get to depth of it, but we know right now how to print anything we want using a print formatting technique, for example. All right. With that, we will get into something important, that is conditions and iterations. Many programs, for example, we should learn to make the program behave the way we want it to, for example. That is very important. So in Python, the conditions that are used is else and if. These are the 3 conditions that are used in Python. So, if you guys have a programming background from C, Java, etc., to represent a block of code there, they use something, they use a pair of curly braces, isn't it, everybody? Whereas in Python, we make use of indentation to represent a block of code. What does that mean? Suppose somebody have taken a marks of 84. Suppose I am writing a program. If, okay, let's make it a little more intuitive. I'm asking a user to put the integer input, enter your marks. Okay, the user will input. Okay, then I want to say if the marks is greater than 35, I want to say congrats. This has to be in a print statement, right? So print congrats, you have passed. Okay, this is all I wanted to do. Then let me just come out of the block and say we are out of the statement. Okay. What all we should understand here? We have asked the user to input some marks. After that, if the marks is greater than 35, just understand one thing. If, else, if, for loop, while loop, function definition, class definition, all of this terminates with a colon followed by an indented block. What does that mean? Forget about these things right now. Right now we are in the if statement. If statement is always terminated by a colon, okay, followed by a indent. What does that mean? It just means that this print statement belongs to this condition. Only if this condition is satisfied, this statement will run. But this print statement is not, it doesn't belong to this condition. So it will be always run. Okay, let me ask the user. I'm going to say 88. What happened? 88 is greater than 35. So it went into this print statement you have passed, came out of the print if statement and printed this. Let me run that again. I'm going to give marks as 32. What happened? 32 is less than 35. So this condition is not true. So it did not get into this block of code, directly came out of the if statement. This is if, but this doesn't look really well, because if the condition is satisfied, we are telling it what it should do. But if it is not satisfied, we are not saying what it has to do. So adding else statement is better. How do we do that? We'll say else print, sorry, you have failed, for example. Now you see 32. What is happening? First, this input marks is evaluated against this condition. It is not true. So it did not go into this statement. Came out of the if statement, went to the else. Else is true, because if this is not true, it has to go to the else. So it printed this and came out of the loop. Right? As simple as it is. I'll give you a minute and then we will go ahead with the else if statement and then some of the important keywords. Okay. Let me ask you. It is if, else, or if you want to provide multiple conditions, it is else if. Okay. Suppose I want to have check if the marks is greater than 35 and less than 85, print first class. Okay. If it is greater than 85, print distinction. Okay. Else failed. When you write a program to implement this, if the marks is greater than 35, we want to call him passed. Sorry, if it's greater than 35 and less than 85, first class. If it's greater than 85, distinction, otherwise failed. Can you try and see? All you have to do is add this else if class. Else if is not required. It is required because if this and this holds true, print it. Else if this holds true, print this. Else you print this. So are you able to do this? So basically, all we had to do was marks greater than 35. We wanted to add, right? And if marks is less than 85, we will just say past. Instead of else, we will add one more statement. If then here, if marks is greater than 85, say we'll print something. Awesome. You are unique. I'm just mentioning it. Else wanted to print it. So if I say the 8 went to the if block, if I say 18 goes to if block. Is this clear, everybody? Have you understood the indentation? If else, elif. See, if you do not want to put these multiple statements like this, you can also use things like, for example, you can also do it this way. If marks is greater than 35, if marks is less than 85, like this, then print you have passed, for example. Instead of this statement, you can also write it this way. This is called nested if, right? A if statement inside of another if statement. I hope you're all with me. So we are done with this. We shall move forward to the further concepts. I'll not spend a lot of time here. So okay, all right. Okay, so Vishal says, I think we can skip this part or rush through. Okay, so do you mean we can skip the Python programming side of it because we've explored data structures enough, and should we move on to data science? Is that what you mean by that? Okay, and Raj says the same. What about what does others feel? Okay, that's a collective opinion. So I would definitely, I mean, we will go ahead with that in that case. However, we have explored data structures. We know what conditions are. Okay, looks like all of you from the similar background as well. So as an introduction, I'll just talk about what for loop is, and maybe you can explore these keywords: break, continue, and pass. These are keywords which are used to control how your conditions and iterate conditions behave inside a program. Then there is for loop, for example. If all of you are, okay, just tell me one thing. Do you all know what iterating through an object is, like for loop? While loop, for example. Okay, all right. So it's good that I got the opinion. Otherwise, yeah. So we will skip it in that case. So just in case if somebody is not sure, you can go ahead explore. Iterating through an object is, passing through each items, do something, okay, to do some operation on top of it. So with that, I will skip to the I don't think this is all, right. Learning to write the functions and all that is not the part of this course anyway. So I'm not exploring, going through all that. So straight away, we will hit the NumPy and pandas. Okay. You guys know what NumPy or pandas is? NumPy is also called numerical Python. Okay. Yeah, that says it's a package. Excellent. So basically, you see, when we discussed about the data structures here, Python has all the data structures, whatever data structure it has, we have discussed. There is a flaw. I mean, when I say flaw, it's a general purpose programming language. However, suppose I have a list here, which is 1, 2, 3, and I have another list, which is 4, 5, 6. Okay. I want to do some row level addition, for example. What should I do? If I do L plus L1, it's a concatenation of two lists, isn't it? So if I maybe for I in L, um, we have to think about a logic to do a simple row level operation or a column level operation. I mean, if you want to do a matrix multiplication, for example, it's not possible without arrays. So Python do not have the native array as a data structure, and that's why NumPy was introduced. It helps you doing numerical operation using n-dimensional array, which is also called as ND arrays. Okay, so NumPy is all about arrays. All right, NumPy is all about arrays. So let's understand how it works. Okay. See, NumPy is an external package. When we say external package, what is it? First, we have to understand. And as part of it, see, there is a package called math, for example. Import math. If I import this module called math, I can use all the functions that are available from this function, from this module. For example, math.square root of 64, I'm able to get 8. What is math? Math is a module. What is a module? Module is a collection of functions relevant to something. If I want to write my own module, for example, all I have to do is take a notepad. Say I have a function here, add, and I'll say it should accept n1 and n2, two items, and it should return n1 plus n2. This is what this function should do. And one more function, multiplication. This will also take two functions, two arguments, parameters, and it should return the multiplication of it, for example. Okay. See, this is my own module we are writing, and I'm going to save it. Save as my math, for example, .py. Whichever file is stored as a .py file, that's what, that is a module. Okay. Now we have created our own module, for example. Now if I go to Anaconda prompt, for example, and if I go to this folder, now if I run, sorry, go to the Python shell and say import my math.py. What did I name it as? Sorry. I have imported my math. Now you see my math dot. I can use add function. Add two numbers. I can use multiplication function. Multiply two numbers, for example. So this is how a module is created. Okay. So similarly, we have a package NumPy which has many modules inside of it. Okay. See, a module can be imported in different ways. For example, I can say, sorry. Um, so, for example, I can import it like this from math import maybe only this function. In this case, I don't need math dot square root. I can just use square root of 64. This is good enough now. I like that. So likewise, if I have to make use of NumPy, I have to first import NumPy. Okay. And convention by the standards, generally NumPy is imported using a alias name called as NP. Okay, it's an alias to import NumPy, so it's NP. All right. Now we have imported NumPy. Now what I'm going to do is, for example, um, let me add this up here itself. Now let me convert this list as a NumPy array. What I'll have to do, we call it as np.array, and the object that I want to convert is basically right. So I've converted this list as a NumPy array. You can see it's represented as an array with one square bracket. If I look for the shape of it, it's one dimension. Okay, it's a one-dimensional array. If I want this to be a two-dimensional array, one thing is I can do the reshape. I can add it here as well. 2, 2, for example, 2, 3. Now you see it's a two-dimensional array. It has two square brackets. Please notice that it has two square brackets, and you can see it has 2 rows and 3 columns. All right, which can be reshaped again. Reshape this into 3 rows and 2 columns. It's possible as well, right? You see, this is an ad hoc operation. I did not assign it to a variable. So this is just temporary. the array still remains to be 2 rows and 3 columns itself. Please do remember, whenever it's a multi-dimensional array or a matrix, the first thing that comes is the rows followed by the columns. Okay, so we have 2 rows and 3 columns in this array. So what did we explore on list, strings, everything? We'll do the same thing. We know array is a ordered data structure. So if I say n of, for example, first row, second column, I'll have 6 because 6 is in, this is 0th row, this is the first row, this is first column, this is second column, this is the third column, which is 0th, first, second. So I have the first row, second column, that is this item 6. Okay, so let me create one more array. Yeah, I'm going to name it as RR, and probably let's create an array of dimensional. So we've already converted a list and created a list and converted it as an array. So now let me directly create it. mp.array is the command. The first argument to be passed is the object. So here I can say I want to have 1, 2, 3, 4, 5, 6. Now if you check this, it will be a one-dimensional array, and I have to pass the shape. So I can say I can pass it over here, or I can say ARR is equal to ARR reshape rows and 3 columns. Is it 3 rows and 3 columns maybe? What happens if reshape parameters are lesser or more than the array size? We've just seen it. If I try to do it 2 rows and 3 columns, it's an error. In the case of tools like R, it would have still accepted it, ignoring the rest of the items. But here, it's an error. Cannot reshape the array of size 9 into shape 2, 3. There are arguments like, for example, size of the array is 9. Here is the array we have. We have to just learn to understand the indexes. That's the, I think that's where we will give some focus. Otherwise, we should be good. So, for example, indexing. See, it is pretty much like what we learned in list or strings. Only thing is it is multi-dimensional. So, for example, if you want all the rows of the first 2 columns, what would you do? 0, 1, 2. So what this will do? it will give you all the rows of 0th column, first column, end index is exclusive. So you have all the rows of first two columns, right? Okay. Similarly, all the columns of these two rows, if you want, what would you do? Can you give me the syntax that I will ask for? I want all the rows of columns of these two rows, for example. I want 4, 5, 6, and 7, 8, 9. I want this much from the array. Suppose if you'd like to access only this much, how would you do it? You can just paste the code in the window, the chat, so that I can access it. That's it, right? So all we had to do was array of first row from first to everything, all the columns. That's all we had to do, right? Okay. Suppose I want 4, 7, and 6, 9. How would I get it? I just need 4, 7, and 6, 9. What can we do? Array of we want first. Let's say I want first row. Okay, let me say 0th row and second row of all the columns. First, let's access this much. So what do we have? 0th row and first row of all the columns I have. Suppose I only want 0th column and second column. How would you get it? Can you try doing it? Okay, I didn't teach, we didn't talk about one thing before. That is the step size. For example, suppose you have a list here. L of one, okay, L of everything, this is right. I can have something called as the third argument. By default, it is anyway 1. This is the step size. If I use 2, what happened? 1, 3, 5. If I use 3, then it will be 1, 4. Right? This is step size or skip size. So you can also make use of the step size is what I was trying to say. And what I've asked for example, will not do it yet, 0, 2, and are you trying like this, 0, 2 again? So this is our array. So we've asked for 0th row and 2nd row of 0th column and the 2nd column. So what we were expecting was 1, 3, and 7, 9. However, we just have 1 and 9. Sorry. It can also be done by doing this step size thing. Here what we did, we are taking 0th and 2nd row, these two rows, columns. I've said all the columns skipped by 2. So you have first one, skipping the second one, you have the third one. Index wise, you can try doing, such things. So maybe another few minutes, we shall move on to pandas. And pandas is the workhorse of data science. So that's where that's where our data science journey begins. Okay. Okay. So any questions on the indexing, anybody? Pretty much like list or strings. Only difference is you have two dimensions here, rows and column. Is this clear to all of you? Any questions? Like reshape, you can also try doing resize. Sorry about that. Shall we go ahead? So we have seen the indexing part of the NumPy. So I think we are good to go ahead looking at some of the functions available. So you have, we've been seeing functions such as the cumulative sum, for example. Now what a cumulative sum is. It's giving you the cumulative sum of the data. Similarly, there is cumulative product. Similarly, there is argument max, for example. This gives you position of the data, that item that is maximum. So the maximum item here is 9, which is in the 8th position in one dimension. So if you really just need the max, you can look for max, and that is 9. Okay. Similarly, comparative operators, for example. Suppose I want to extract all the, I want to grab all the even numbers from this data. What can I do? All I have to do is array divisible by 2 is equal to 0. Is equal to 0, right? So I'll get a Boolean result. So the 2, 4, 6, and 8. That is 2, 4, 6, and 8. These are the items which can be divided by 2 with a remainder of 0, which are even numbers. What if I want to access this item itself rather than just getting a Boolean result? I only want 2, 4, 6, 8 in a new list. What can be done, everybody? Okay. When I do not get many responses, I'll be left in confusion, thinking whether I'm going too faster or am I going too slow. So, any point of time, please feel free to tell me if we are not in the same page, on the same page. Okay.
Create another array and like iterate it. Keep populating that array whenever %2 is equal to 0.
We can create another array, can be done, but in simple thing, see these are the items that are satisfying the condition. In Python, how do we access an item from a ordered data structure? What do we use? Accessing item through index or whatever, we use a square bracket. Yes. If I want to access, for example, from this array, if I want to access this 2, I would have said ARR of 0th row, first column, 2, right? Instead of this index, this time we have given some other condition. So it should be within the square bracket itself. So if I put that, then you can see we have the 2, 4, 6, 8. But yeah, you can have another array, and passing this condition, you can have another array as well. Yeah. Okay. So then there are a lot of other functions. I don't know whether we would like to explore all the functions here. I don't think we should be. So array dot, for example, T. This is a transform function. We could have also done, transposing an array. You can also do this. If you call this transpose function, then you have to call the function by parenthesis. So transposing an array. Similarly, maybe concatenating 2 arrays. If you have 2 arrays with same size, you can do the concatenation, for example. For that, you will use np dot concatenate array 1 and array 2. Array 1 comma 2. If you have two arrays with same size existing. Okay, so there are a lot of other commands. We'll not get into all of them. See, there is something called flatten. Flatten meaning a multi-dimensional array will be converted as a single dimension array. So actual array is 3 into 3 dimension. Flatten, when you say, it will flatten it out as a vector. Okay, so basically NumPy is to work with arrays. So matrix based arithmetic operations, NumPy proves to be really helpful. Okay, let me give you one simple task just to make sure that you know you learn to work with the indexing part of it. Maybe let me add one more row here. Okay, array of 0, 1, 2, 3. Third row I'm adding, and that is going to be 10, 11, 12. Third row, sorry, I do just a moment. Seeing out something here. 0, 1, 2. Okay, so all I want you to do is can you take suppose 2, 3 and 8, 9 from this array. I just want you to extract or grab 2, 3 and 8, 9. And with that, we'll look at a couple of more functions in NumPy. Moving on to minus 10. See, before we have taken 1, 3, 7, 9. This time, these two and these two and these two. This is all I want. 2, 3 and 8, 9. Yeah. So I have an answer from Vishal. Okay. So this is 2, 3 and 8, 9. So taken 0th and second row of all the rows, columns from first. This works well. Then I have our answer, and that is array of first rows and third row, right, of all the columns. Both works well and good. So we do have an understanding of indexing with respect to NumPy. So this is excellent. So we can go ahead to the further concepts. All right. Before that, it's been 3:30, 1.5 hour past our lunch break. Past the starting of the class. So would you like to go for a quick break and come back? All right. So we'll go for a break. Morning. We'll come back after 10 minutes, everybody. All right. So I shall see all of you after 10 minutes. Thank you very much, everybody. Hope all of you are back and we can move forward. Okay. So to add another column, np.append. Yeah, thank you very much for exploring that. However, did I not look for, okay, I think I have looked for ARR dot. Yeah, thank you for exploring that. And yeah, this is how we add another column. Axis is equal to 1, we are able to add a column. If the axis becomes 0, that is adding another row. So throughout NumPy and Pandas, whenever this argument called as axis is in place, now you see we are able to add another column. Okay, I make this 0. However, now you'll need one more item. Make it 100, 111, 12, and because there are 4 rows here, 13. Oh, uh, 2, 3. Just a moment. All the input array dimensions for the concatenation axis must match exactly, but along with dimension 1, the array at index 0 has size 4 and the array at index 1 has size 1. Okay, so just a moment. You see, I'm able to add one row as well, and we have another column as well. So basically, there are a lot of functions you see you don't need to remember. As in when it is required, you should be able to explore it. And whenever you see the argument axis is equal to 0 or 1, it means you're 0 meaning row, you're referring to rows, 1 meaning you're referring to columns. Okay. So with that, we shall go ahead and explore further. Okay. So there are functions like np.take, for example, np.delete, and so on. I would let you explore these functions. Similarly, vstack, hstack, for example. I think at least vstack, hstack is something which is very useful for us if we explore it. Let us have maybe 2 arrays. A1 is equal to 1, 2, 3 np dot array of 1, 2, 3, 4, 5, 6 shape, 2 rows and 3 columns, right? So this is our array 1. I'm going to have another array A2, which will be 10, 20, 30, 40, 50, and 60. So I have 2 different arrays, A1 and A2. Vertical stack is I can say, for example, np dot v stack. Stack arrays in sequence vertically, row wise concatenation in fact, A1 comma A2. So I can have this is two-dimensional, so it requires two parentheses. Okay. Now you can see row wise we are able to add arrays. Similarly, if I can go for horizontal stack, again a tuple has to be passed, right? Same thing goes here as well. So tuple has to be passed. Tuple meaning should be closed within parentheses. So A1 comma A2. This is a horizontal concatenation, isn't it? So that is also again from NumPy. Similarly, you have functions like sorting, etc. So np dot, you can also look for all the help in NumPy. For example, np dot sort. So for all the functions, you have such help available. You can see by default, this should be a quick sort. Also heap sort, merge sort, time sort, all of them are available with the help of the arguments. By default, it will be quick sort. You can say type and kind and mention what kind of sort would you like to have. Okay. So, okay. So we have explored a bit of NumPy so far. So before we move to the pandas, maybe one module that I would like you to know about is called the random module. Are we good with this? Shall we go ahead? Okay. So random module can be imported using the name again, random. So random module helps you to work with random numbers. For example, there are many other functions available. I'm going to show you a few which are important. Suppose rand int returns a random integer in range a comma b including both points. So if I say rand int, I say 1 comma 10. I want three numbers. Takes three positional arguments, but four were given. Yeah. Just a moment. Just say 1 to 10. So it's comma, suppose. So you have a random integer in this range of numbers. Suppose 1 to 4. Simple. A random integer every time you run it. Similarly, random dot random itself. See random or call for random dot ran n. I think I should have done from np import random. Module np. What's wrong? Okay. Or let me just say np dot random dot rand int. The low returns. It's a different module we just saw. This is the one I wanted to show you. So returns random integers from low to high. Low is inclusive, high is exclusive. So if I say I want the random integer from 0 to 5, 0 is inclusive because low is inclusive. You should never get 5. That's what it is. Similarly, np dot random dot rand. What does rand do? Random values in a given shape. For example, if I ask for 5 numbers, 5 random numbers, every time you run it, you have 5 random numbers. Similarly, which is the other one, which is remaining rand n. Rand n returns the random numbers in a standard distribution. You know what standard normal distribution is, right? For example, if I ask for 5 numbers in a standard normal distribution, how do I check whether this is in the standard normal distribution or whether it is following bell curve? I can take one visualization library, which I'll explain later, and you may not have this library readily available. You may have to install it. But for now, you can ignore it because once we get into analytics and machine learning, this is also one of the packages we'll use often. Okay. Now, what I wanted to do was C bar dot distribution plot for np dot random dot rand n of 5 numbers, for example. You can see it has just generated some random numbers which is following the normal distribution. I hope you got this. So where can we use rand n? Whenever you would like to prove some theory, but you do not have a data set, you can generate your own random normally distributed data so that you can work on that experiment to prove something. As we go ahead, you'll understand the significance. So any questions here? Install this package right now. Install it. All you have to do. If you are doing it from the app on the ground, all you have to do is, for example, on the ground, just have to say you can install one. And for me, it should say requirement is already satisfied. What does it say? Okay, there is some advice for PIP. Okay, requirement already satisfied. You can see it, right? So that means I already have it. And in Jupyter Notebook, if you're trying to install it, the line has to start with an exclamation. Okay. So okay. So in NumPy, we have seen a couple of comparison operations. We have seen indexing. We have seen functions. not to the core, but we have seen a couple of functions. I think with that, we are good to go ahead, get started with parallels. Okay, I think we can go ahead. Like we have seen the even odd. Likewise, you can also look at other functions. Suppose you want to access all the items which are greater than 3. You have a Boolean result. If you want to access it, put that inside the okay. So likewise, you can go ahead, explore other functions in NumPy. So now is the time we are moving towards pandas. Pandas is another package out there, which is also called as the workhorse of data science or in data science in Python. Okay. So what does pandas provide? If you look at, first thing is let's import the modules. Import pandas as PD. Okay. So once you import it, so pandas provides us two data structures. One is called series, another one is called data frames. Okay. So what is a series? Series is like a vector. Okay. Vector, when we say vector has only one dimension, isn't it? So if I say S is equal to PD dot series, sorry, PD dot series, you can see the argument data and index. So if I pass some data to it, say 2468, and if I look at the series, this is my series. You can also pass some index if I want. You can say index is equal to A1, A2, A3, A4, for example. This will be my index. Right now the index is 0, 1, 2, 3. I can change it. So all of this needs the codes as well. So this is our series right now. Series is nothing but single row or column, right? Okay, so now let us try to understand the data frames. What is a data frame? Data frame is nothing but a combination of rows and columns. Okay, data frames is nothing but the combination of rows and columns. So that means it's a data set itself. The data frame is nothing but the data set. For example, right now we were looking at some random package, right? np.random dot and n. See, the data frame, first argument is data itself. This data, I did not have data, I just passed some random numbers of say 2 rows, 3 columns. Let it be. We got a data frame. I can name the columns, for example. Column names is equal to say A, comma B, comma C. Without column name, it's not, doesn't look good, right? So I have a data frame which is generated by a randomly generated data in standard normal distribution. Okay. So if you have the data, we could have passed the data as well. I'm not naming these data frames right now. If you want, we can do that also. See here, all I want to do was, okay, pass some items. So I can do that. So you can just say the first argument is data is equal to 2, 3, 4, 5, 6, 7. Okay. We have the data passed as well. So the easiest way to create a data frame is basically use a dictionary. That's the most easiest way of creating a data frame is making use of a dictionary. First, I used pd.dataframe, passed random numbers in a standard normal distribution in 2 rows and 3 columns. I named columns as A, B, C. If I want, I can name the index also. Index is equal to, say, row 1, row 2, row 1, row 2, comma row 3. There is only 2 rows, right? So 2 rows and 3 columns, we have the data created. Let's look at how to use a data frame, for example. pd.data frame, I'm going to have some random data. Say this is a weather report. Okay. I have a column called days. I think day makes more sense, right? This is a dictionary I'm working with, okay? Monday, Tuesday, Wednesday. Again, I have Tuesday and Wednesday, suppose. Okay, that's the data I have. Some random data I'm creating. Then temperature. Temperature again. Monday it would have been 18 degrees Celsius, then followed by 24, followed by 28, followed by 12, followed by 21. Okay, some normal temperature, some temperature we've passed. Then suppose I have one more column called cloud, and I'm going to just say S, S, O, S. Got 5 records, right? Maybe one more column, rained. I'll just pass these things itself, this data itself, so that it becomes easier for us. Okay. This is the easiest way of creating a dictionary. What did I miss? Yeah, it's a dictionary. So not past to be, but it's a colon. So and the same thing over here. Now you see that's a data frame. The easiest way of creating a data frame is actually passing it as a dictionary of key and value pairs. So I have a data frame of 5 rows and 4 columns. And as data frame. I hope I'm not going very fast. Please tell me if that's the case. I'll slow it down. And okay. Indexing also works similar here. For example, if I say df of rained, it gives me this column. Then I can access, give me only first 3 records. I can do that. Indexing is a little tricky here because there are more options. I will talk about it. And you may not want to type this out. I'll just pass it on to you. Okay, if you're doing it along with me, I'll just pass it on to you. And just a confirmation, are you all able to work along with me so far, whatever we've done in the morning, are you able to type it and run it along with me?
Yes, sir. We are able to run along with you.
Thank you very much, Vishal. Okay. Okay. So data frames is the backbone of a data science because what data science all about. Yeah, we have created and clear. Is there anybody else facing that issue? Okay. I think Raj, you may have to check the connection or maybe just do a refresh. Yeah, all right. Thanks. Okay. So I was saying data science is the backbone of any data science tool. So we are able to create a data frame. So now let's go ahead accessing items. Okay. There are different notations. Okay. df.shape, we know the commands. Similarly, for a data frame, if you do df.columns, this will show you the column names of all the data. Similarly, there are commands like, for example, df.head. That gives you first 6 records, but right now it's a simple data, so I don't need the commands like head. But if I say first 2 records. Similarly, if I say df of tail, last 2 records, and so on. Okay. Now coming back to the accessing data in a data frame. There are many ways, okay? Accessing data. One is just using the square bracket like we have been doing all the time. Second one is called LOC. It's the label based indexing. Then there is ILOC. It's purely integer based indexing. ILOC is something we are familiar of. There are IAT, IX, and so on. Let's not go through all of them and get ourselves confused. First is this. Okay, this is my data frame. First is the square bracket notation. Can I say df of all the columns of first comma third row? Sorry, all the rows of first comma third column. There is a problem. It's an invalid key. What's wrong here? What went wrong? So rather, I could have done it. For example, a purely integer based, we have to use ILOC. However, the first thing. So now what I wanted was, for example, the first column, comma, third column, zeroth column and second column, for example, and cloud. I wanted all the rows. Okay, all the rows is anyway there. That is not required. Suppose I just wanted 2 to 4th row. We have second and third row available. This is just pure square bracket notation. I can do df of one column itself, day. This is fine. Maybe df of days first 3 records. This is fine. df of first 3 records of day and temperature, or maybe cloud. This is fine too. Okay. So there are different ways of accessing items. So we have kind of understood the square bracket notation. We are using square bracket to access multiple columns at a random index, and the sequential rows of a choice. And now let's look at the further other techniques, and then I'll let you try this out on your own. LOC works pretty much similar. It's a label-based indexing. If I say df.loc and access a group of rows and columns by label or a Boolean array. So if you go here, you'll be able to see a lot of help. There'll be examples here where there are examples given this way, right? So we have a data frame created, bd.data frame. You have some data frame. You have the row name, you have the column name. Okay. Now, there are Cobra, Viper, and Sidewinder. Okay. Cobra's maximum speed and shield, Vipers, and Sidewinder. Then you have single label. Now you have the .loc of Viper. Okay. So using .loc, even the index, if it has a label, you are able to access it, right? So this row you are able to access using the label of the row. It's a row name. In the above examples we had, I did not have a row name, right? I don't have a row name here. This can be done using LOC. Similarly, list of labels using the double square bracket notations. This row and this row, that is Viper and Sidewinder. These two rows I am able to locate using the label name. Okay. Cobra and Viper, maximum speed we wanted to return. It's possible. So you can see Cobra and Vipers, only maximum speed. Again, everything is based on the label itself, isn't it? So let's look at a couple of examples. That was just to let you know there is a detailed help with examples available for everything here. Okay. So for example, let's do Okay. So more or less, this LOC also can be pretty much used like the square bracket notations that we have been using. For example, say I want the first 3 records of say case range. So I have the same output as which was returned by the square bracket notation. However, the key error, days not in index. This day. Similarly, ILOC, if we look at, then this will do everything. I mean, this is like same as whatever we've learned in NumPy and other places. For example, if I say df.iloc 2:4, I get the second, third record row, right? So if I say comma, 0th comma, second column, now you see I have these 2 rows of 0th and second column. So basically, when we talk about ILOC, labels is completely not required. When you talk about LOC, it's a label based locator. And when you talk about the other one, that is just square bracket, it's like any other data structure of Python. LOC also can be used. See, sorry. So there is also SQL based syntax, which is dot. For example, I can also say df dot day, for example, of two, like this. That is SQL based syntax, by the way. Shall we? What we'll do is we'll take a bigger data set so that we'll have more, we'll have a better interest in doing some subsetting, right? Sorry, the accessing of items. What I'm going to do is, if we import a module or data sets from the scikit-learn package. Scikit-learn package is the machine learning package of Python. From the scikit-learn package, data science module, I'm going to import some data. How I am importing this, explain later. I mean, this is some function. First thing is I have to call it as a function using parentheses. Then this will have, if I go to the print of d dot description, get everything. Okay. See, this is the data. Basically, the data has 14, actually 14 columns, but this column they have given separately. These columns are available by saying d dot data. This is some data where of some houses sold in the city of Boston. They have taken all these details. All right. So now what we would want is, I would say df1 is equal to d dot data. Is that it? Now you say df1 is an array. Okay. I wanted a data frame, so I can say pd dot data frame of d dot data. Columns is in d dot columns. Okay. So it's feature names. Okay. So you have all the data, but the last column is missing. For that, what we can do is df1 of one more column, price of the house, and that is available in something called target. That's where I said, do not worry about, how do we know where this is available, where that is available. Just think that there is some data available in this object D. So D dot data, if you say, that data will be loaded. The column names of that data will be loaded by saying d dot feature names. There was one more column missing, that is this column. So I took all of them. Okay. So now if you look at df1, we have all these attributes available. Okay. We have all these attributes available. So it's a little bigger data so that we can start working on it. Just check whether you are also able to load the data, everybody. So are you also able to load the data? All right, thanks. So let's do some basic testing again. Just quickly give you some tasks. Upon doing it, we can continue with a few features like the inbuilt functions in pandas, and then we should be starting with the statistics and data analytics from tomorrow, everybody. So um, we are done with the basic, the learning of data structures and programming, whatever had to be done. So, sorry. Okay, I think by mistake I've closed everything. Okay, so here is the data we have. We have 506 records or rows of or observations. Rows are called records, observations. Records or observations are entries in the typical data science terminology. And we have 14 columns, which can be called as features as well, variables as well. So this is the data. Can you grab the columns? Let me just name it. Grab the columns. That is maybe tax, crime, and LSTAT. Or all the records. Can you quickly do this? You have to take tax, crime, and LSTAT for all the records. You can use either LOC, ILOC, or just the square brackets also. If I was asked, I would have just used the square brackets, maybe. Let's say tax, comma, crime, comma. That's all we had to do. If they've asked for a particular column, then I would have also done the second, fourth, sixth. This would only take, for example, 2 to 8 records. Way I can do. But if I want particular records, then what I can do is probably df1. There are many ways of doing it, by the way. I can go for LOC, df1.loc, and I can go for first, third, eighth, first, third, eighth record, suppose. of, say, crime and say tax. I have missed out on a comma here. Now you can see we have random rows selected for random columns as well. This may take a little bit of time for you to, this may create a confusion. What is LOC, ILOC, and just the square bracket notation. I'm sure as you start using them, you'll get a hang on it. But again, LOC is generally used when you have to mention the labels, be it column or row labels. ILOC is the most simple one because you have been working